Hey, here's an explanation from the OWL pages number 7. Number 7 would be considered kind of a tough one for a couple reasons. Let's analyze it first, and then I'll show you why. It's a square root function. It's got the square root in there. And then the hard part about this is this 3x minus 6. It would seem that it is subtracted by 6, so you'd move 6 to the right. But when we take a look at and tease out that 3, which is a common factor in both terms, we get 3 times x minus 2. So what's happening there is, let's see, that negative looks like it's a square root. Let me rewrite that. It's negative square root. This is a reflection over the x-axis. This x minus 2 on the inside of the function means we're going to go right 2. And this 3, let's see, it's on the inside, it's being multiplied. That's actually a horizontal compression. So I'm going to take you through kind of step-by-step way to visualize it, and then another way to get the points. Let's visualize it first. So first, the square root function looks like this. I'm imagining just the square root function. I know that those are important points. I'm not going to work on them now, but I'm going to dot them in. Then I'm going to reflect over the x-axis, so that makes that square root function now just flip in mirror image this way. And then I need to take the horizontal compression next, because that, in the order of operations, we've got to do reflections and dilations, because they're the multiplying factor in the function. So a horizontal compression is going to be as if I'm kind of pushing that way, compressing it on the function. It's going to kind of bow out a little bit. So it's going to be something like this. And then I take it right 2. So that one that has now been bowed out is going to look something like this. So I do that all so that I can identify that 2, 0 is going to be my important point, the one that kind of anchors me in. That's helpful. Now, the second reason why this makes number 7 tough is because we had to tease out this piece in here to make so we could see what the 3 transformations are. I'm actually going to go back, and to find points, I'm going to go back to the original one, negative 3x minus 6. Because if I just throw out some points there, like whole numbers 3, 4, 6, they're going to be weird square roots. So I'm going to do a little upfront work here and say, I want this argument inside the square root, to be something nice and easy square rootable. So my side work here is to say, one of my first points is to make, what happens when I make 3x minus 6 equals something nice and easily square rootable? 1. What if I make 3x minus 6 easy square rootable? 4. What if I make 3x minus 6 nice and easily square rootable? 9. That means I'm skipping one step here. I'm going to add 6 and divide by 3. X needs to be 7/3. X needs to be 10/3. And x needs to be, that's 15 divided by 3. Oh, that's 5. So it might be good to pause me right now and see if you can't identify, when these points are put in to the function, what the y coordinate is going to be. 7/3. That's 7 minus 6. That's a square root of 1, negative 1. 10/3. That's 10 minus 6 is 4. That's negative 2. and 5, that's 15 minus 6 is 9, that's negative 3. Those came out kind of nice. And it's much easier for me to find 7/3, which is 2 1/3, negative 1. 2 1/3, negative 1. 10/3, which is 3 1/3, negative 2. And nicely, 5 and negative 3 work out. That's going to be, I'm going to make it a little more curved. That's going to be my square root function. This is, what did I call it? Negative square root 3x minus 6. That's what it